Okay, thank you very much for having me here, and this is my honor to coming back to the Hokkaido, and it's really the summertime and beautiful weather here. Thank you. That's the title of my presentation, and this is not really research presentation, so just relax and enjoy how it really happened in my lab and Earth Medical. So, really going back to 2001, when I first came to Stanford for my PhD. It's such a beautiful campus if you ever visit it. If you haven't, if you go to San Francisco area, save your time for about 2 to 3 hours and visit Stanford. It's really amazingly beautiful. And I can tell you, the students there are not really enjoying the weather at all. Students there are really suffering for their studies. Well, that's like 20-something years ago, me, young and ambitious back then. And for me, I was really lucky to meet Professor Dwight Nishimura, who was the faculty at the EE department of Stanford. And he was teaching the medical imaging class, and one of the big topic of the class was MRI. And if you ever know Dwight, he is the best teacher ever. Like he give you, like his class is like amazing in a sense that you're just simply taking his lectures, then you learn the intuition of the topic. Like it's a really amazing teacher. And I loved it. And after the class, I asked him this question: how can I get the sub-millimeter fMRI using current technology? Well, again, it was like 20-something years ago. The resolution that we had for the fMRI was like 3 by 3 by 5. So as a simple-minded graduate students, if you can really get to the sub-millimeter resolution, that's something that you can change the field of fMRI. And his answer was quite straightforward. Like as an MR physics professor, he answered that, well, you can do a lot of scans, long scans, and averaging. You can get the result. But think about the fMRI. You're really seeing the phenomena that changes in the brain, and you cannot really scan 10 hours of the same subject using fMRI. So I thought that may not be the right way to go. So I kind of set my mind. Okay, I will do this one for my graduate school. I will do functional MRI. And try to find a new way of doing the fast, like high resolution imaging. And then I asked him, okay, I ranked number 1 in your class. Can I join your lab? And that's usually the well-known recipe in his lab. If you rank number 1 in his class, he usually take you as a graduate student. So I was like, and then his answer was like the opposite then. To my expectation, he said, okay, sorry, but I don't have, funding for a new position. So I was like, really sad. I was really lucky in a sense that we had another MR physics, professor in our department, John Polly, if you know him. He's another, very famous, MR physics professor. And he became the faculty in 2001. I was like literally the first graduate student of John. And so I went to him and John, and then this time I don't want to miss this opportunity as there was only 2 people in the electrical engineering who does MRI. So I asked John, and I prepared. I'm really prepared for this interview. So I come up with some new idea of doing the fast imaging, and gave him the 10-minute presentation, how I can do the research using this idea. And John was really happy for bringing a new idea to his table, as not many graduate students try that, right? So yeah, he really welcomed me to join the lab. But at that moment, I did something wrong. Literally after John said, you're welcome to join my lab. And I literally said, but I want to do the fMRI. And his specialty within MRI was cardiac imaging or MSK. And then I said, I don't like really don't have much interest in cardiac or MSK. I'll do the brain imaging. And it's like, if I looking back now, if somebody comes to my lab and my office and asks if he want to do the MSK, I will say, okay, I don't do MSK. You may need to talk to the other guy. But he was really generous to, have me in his lab. So we set it up, the fMRI, setup for the lab for the first time, so that I can do the fMRI research in the lab. And after a few years of time, finally, again, I got a little bit older. I wrote my first paper. First paper, it takes years of efforts. But again, there was like a new fMRI technology that is called as balanced SSFP fMRI. I tried to solve one of the real-time compensation technology of this particular technique. And I got super excited. Again, I suffered a lot, as I mentioned, graduate students at Stanford. They are not happy about the weather because you are suffering and the weather is great. And all these tourists are having the fun, but you are not having the fun. But at least the moment that I published this paper, I was super excited and I determined myself to continue to the fMRI research. And back then, we had a Mickey Lustig in my lab, in John's lab, in our lab. And that's the time when Mickey came up with the idea of compressed sensing for the first time in the world. And he was really making a big impact in fast imaging. And he was really changing the world. So, wow, that's another very exciting idea. But I will continue to do the fMRI. And by the way, if I go further down to my slide, let me just introduce a few people in my author list of the paper, the first paper of mine. You can see the Steve Connerly there. He is a professor at Berkeley. And Carla Miller, she is the professor at Oxford. She is running this human, biobank program for the MRI. In UK Biobank program. And we have Brian Hargreaves, another faculty at Stanford, and of course John. And Mickey is, again, Berkeley professor. And there is one guy in the list who is not a academic professor. That's Juan Santos here. And after PhD, Juan started his own company. It's called Vista AI, and it does the cardiac imaging. And that was another moment that in my life that, okay, after PhD, you don't have to be a professor. You can start your own company and make an impact in the world. That's another very exciting direction to go. Anyway, as we all know, the fast MRI, fast imaging of MRI, is really the core technology of MRI, and a lot of efforts and money has been spent on this topic. We all know, SENS and GRAPPA that is commonly used in clinical diagnosis of clinical, applications of MRI. And afterwards, thanks to Mickey's contribution, we have compressed sensing there. And when it comes to the time of AI, with the impact of AlphaGo in 2015, it's really the new era for the AI contributing to fast imaging in MRI. And when it was 2015, and that was second year of me coming back to Korea, and yes, I knew that this AI technology will revolutionize MRI, and also, as we saw Mickey's example, fast imaging is really the core technology of MRI. It is so often used that almost every scan, you can combine it with fast imaging technology so that you can benefit from it. So we want to focus on this technology, and this time we want to make sure that we do the lead in the changing the world. And as I learned from the Juan's example, when it comes to making the impact in the field, it can be a company. It doesn't have to be a paper from the academic institution. So many of 5 or 6 of my former students has formed a new company called Airs Medical in 2018. I was the guy who was taking the photo of that, so you don't see my face there. And these people are really the brilliant people from my lab. And the leader, the CEO, was Jongho LEE, and he is the guy who came up with the idea of Chi separation. If you do the brain imaging and if you are exposed to the QSM, Chi separation is the advanced version of QSM that is really popular right now. And he gave this highlight talk at the in 2017 ISMRM. They selected 5 abstracts out of 7,000 abstracts. And he was one of them. The idea was really great, and he's really an excellent researcher. And he took the lead of the company. And another guy here is Jaeyeon Yoon. You can see him around here. Yeah, that's him. And he's the guy who developed this QSM net, the first neural network for the QSM that creates a pretty good impact in the field of QSM. So again, these are the really smart people who knew what they are doing and make the progress. And now the company is now 100 people, not just 6 of them. And half of them is engineers and the other half is business people. And this research team is amazing. Like they're all from this wonderful schools, not only from Korea, like Seoul National and KAIST, but also from all over the world who has the cutting-edge technology and bringing the resources for the Airs Medical. And it is fully supported by the Seoul National Hospital, by Professor Seung-Hong Choi, who supported the project and the company throughout the years. And now we are really making the change in the field. So far there are 54 countries that has been approved to install the system. And the system or the software has been installed over 490 hospitals and clinics. And when it comes to the patients, almost 2 million people have been benefited from the technology. It really helps them to reduce the scan time and helping the patients not to suffer from MRIs, long MRI scan. Okay, that's all about my voice, telling you that this is a great company. Try to believe me. Let's try to be a little bit more objective. So Fast MRI is such an important topic, and people recognize it. And in 2018 and 2020, Facebook AI and NYU Langone Health has organized the challenge program so that you can compare different technologies and who's doing the better job than others. And there are a lot of competitors, like all these companies, including Siemens, Philips, and Subtle Medical, joined the competition. They have these 3 different tracks that they evaluate the result. And finally, you can go to this paper and you can read the whole summary of the result. But that will be a pretty long paper to read. So here is one video clip from Facebook AI and NYU. That summarized the result. So let me show you this video clip. Wait. How do I make the sound? Okay, maybe. Okay, you can read this subtitle just in case I'm
engineer with Facebook AI Research, and I'm presenting on behalf of a large team of engineers and scientists between Facebook AI Research and NYU Langone Health.
Hello, I'm Yvonne Louie from NYU. I'm a clinical neuroradiologist.
This is how the results look by the numbers. So we had one team kind of stand out across the board, Airs Medical.
Clearly, Airs was deemed better. And Airs won this on ranking of depiction of the pathology, likely based on that improved sharpness factor. Airs was deemed the best, probably because of these areas more posteriorly are seen the best.
The Airs Medical team had a little bit more separation between them and the other teams, and it seems like the radiologists were able to pick up on that. So they rated errors, by the way, lower is better here. They rated errors better than the other teams across the board.
So again, not my voice, but by the voice of these experts in the field. And here are the scores. This is the SSIM scores. These are the metrics that we can calculate based on the equations. Again, all of them, Airs Medical ranked number 1. And these are real evaluation by 6 USA radiologists readings. And then the scores, if you read the scores here, it's really pretty large difference, like 1.36 to 1.94. So you can see the difference between Airs Medical Recon outcomes as compared to, again, number 2 in the field, number 3 in the field. There are substantial differences in the outcome. You may want to examine the result by your eyes. This is one typical example. This particular subject happened to have some metal here outside of his brain or her brain, and that created the well-known artifact around it. This is one of the winners of the top 3 winners of the challenge, and they created this huge artifact in the brain, whereas Airs Medical Recon was free from this artifact, which really matters in clinical setting. Again, some of the additional images that you can see here is MRA. You can reduce the scan time more than half, again, almost 5 minutes to less than 2 minutes of scan time. The image quality is better in Swift MR as compared to the conventional imaging setting. By the way, Swift MR is the product name of Airs Medical Recon. And this is another example, a little bit of dramatic result that you can decrease the scan time to 85%. Again, it really gives you the high quality images. Airs Medical has been very supportive for the research collaboration, and there are multiple research collaborations ongoing here and there. And this is one of the examples that Swift MR with factor 6 acceleration can be applicable for the pediatric brain where scan time matters a lot, and you can see the image improvement in the result. Again, collaboration has been widened. It used to be only in Korea, but now it goes to all across the world. Some of them is in Japan, including the Hokkaido University shown in this one. So you will see the papers are coming out from this collaboration. If I say a little bit about technical details of Airs Medical's Swift MR, so this is really the secret recipe, how we can do this. One characteristic of Airs Medical Recon is it is all-in-one multidimensional improvement. So there's only one network that serves for everything. And so it functions for the denoising as well as the sampling pattern processing. So whatever your original data is, the network take care of the sampling pattern. So it works for the SENS, it works for the GRAPPA, Kyprina, compressed sensing, partial Fourier, elliptical scans, all of them. The network can process it for you. And then there is super resolution factors that improves the resolution a little bit, and also the network forces not only the data itself, but also the MR physics that constrain the behavior of the outcome. Another thing about the coverage is it covers the whole body parts as compared to other vendors, AI program. This one really has the coverage in the body part as well as clinical pulse sequence, and it goes to the vendors. And we even tried unseen vendors to the network. It still gives you a pretty impressive result. And this is one of the examples how it improved the result. If this is the original input, you can do the denoising and extend for the higher case-based informations, and then gradually you can see the artifacts disappears in every corners of the image. And this particular secret recipe is now available in the archive. So just in case you are more technical person and you want to read a little bit details about the recon, there is an archive that you can find the paper. And if you compare this Airs Medical Recon with other vendors' outcome, the main difference is what what kind of functions it performs. So Eris Medical, Recon performs every corners of these functions, whereas many of these existing, AI tool sets just simply does one of them, and that really limits the application of their product to clinical settings. And this is really the one-to-one, comparison of one major vendor A, or should I say vendor P? Anyway, as compared to them, so Recon is really better. And this is another example of looking at the T2 images. Swift MR really gave you the high quality images. You may wonder why the product outcome is so different between vendor P and vendor Eris Medical. Well, my answer to that is really this page that we have 50 people in our engineering team who only serves one question: Fast MRI. Think about other vendors. You don't have 50 people for the recon. You don't have 50 AI specialists who also knows the MR physics to the bottom of the heart, who want to solve only one problem. And that really makes the challenge, the differences. And also they are the best engineers ever. And that's why I stopped doing any research on recon, because I cannot really compete with them. So as I mentioned, my Fast MRI challenge is now over again. My lab no longer developed recon, because we know our results will never be better than Eris Medical recon. So there's no point of fighting against 50 people. I only have 5 people for the recon. So I believe our Fast MRI challenge is really making the impact in the field. Again, almost 2 million people or patients has been benefit from the technology, and the number of hospitals and clinics using this technology is rapidly increasing. They've been only in the market for about a year in US market, and the number of the growth is really exponential at this point. My hope is your Fast MRI starts with Eris Medical, Swift MR, so that you can also benefit from this technology. With that, thank you very much.